All right, clip number 2 of Chapter 11, Section 1 notes on circumference and arc length. In this clip, we're going to focus on that second namesake for this section title, arc length. Again, just distinguishing between what we did in Chapter 10 with arc measure and arc length. This would be a good place in that margin to kind of distinguish between the two. An arc measure, for instance, of using this diagram here at the top. In Chapter 10, when I would talk about an arc measure from A to B, we would measure it in degrees, right? The Chapter 10 concept. And the degrees was directly related, however many degrees this arc measured in Chapter 10, was directly related to the size of the slice. Basically, whatever the central angle was. Say the central angle was, say, 60 degrees. If this central angle was 60 degrees, then that arc measure A to B would also be 60 degrees. And the reason why that was something that was worth noting in Chapter 10, so the reason why 60 degrees was something to pay attention to is that was 60 degrees out of a 360 degree full circle. That relationship is going to be reflected in this formula that we use. This piece right here, this right-hand side of the equation, this first equation that you see, measurement of arc AB, again means the number of degrees from A to B, and it's in a fraction over the full circle, 360 degrees. This fraction is basically going to reduce down to tell us what fraction this slice is out of the whole pizza, so to speak. So if this was 60 degrees out of 360 degrees, that fraction would reduce down to 1 over 6. That would simply tell us that this slice is a 1/6 slice of the entire pizza, as many pizzas are sliced to be, 6 slices, okay? That's what that side of the equation breaks down as. So this measurement of arc AB here in that numerator is a Chapter 10 type of notation. Now, the left-hand side of this equation looks kind of intimidating. That numerator says the arc length of AB. That will literally mean a distance, a measurable distance from A to B, as opposed to degrees. Okay, so that arc length of AB refers to some distance. So that will be in some unit of length, feet, miles, inches, centimeters, whatever it might be. In the denominator, this should look familiar, 2 pi r. That's exactly what we talked about at the beginning of the last clip. That's circumference. That's the distance all the way around if I started at point A, walked all the way around the circle, and got right back to point A. It's the full distance around. Here's the important thing I want you to just kind of be able to translate here for what this equation means. The arc length of AB, again, is some distance if I were to walk from A to B. Whatever that is over the whole distance around the circle, so that part over the whole, is going to equal the part over the whole circle, but now in degrees. This is what we would call in math a ratio. Basically, it translates like this. Okay, let's say this was 60 degrees. And then that's 60 degrees out of 360 degrees. That means that this is a 1/6 size slice of this entire pizza. What this equation is telling me is that if this is 1/6 of the entire 360 degree circle, this length from A to B should be 1/6 the distance all the way around the circle. It's connecting the two concepts. That whether I'm talking about degrees or a unit of length, they're still the same portion of the same circle. So if it's 1/4 of the circle, then if I'm talking about a portion of the circumference, it should be 1/4 of that circumference. If it's 1/4 of the 360 degrees, it should be 1/4 of that 360 degrees, which in that case would be 90. Okay, that's what that equation is translating. It's showing you that the portions should equal each other. They should be what we call proportional, to use that term. This second formula is the same exact formula. All that's changed is that 2 pi r, that circumference, has been moved over here through the inverse operation. It's being divided on this side, so I'd multiply it to the other side, multiply by 2 pi r. All this does is just the same exact equation. It's just solved for the arc length of that distance. Okay, so this will be the equation that we're working with, essentially. And I'm going to apply these 3 examples. I'm going to jump to the whiteboard in just a second because I know it's a little small. But really what these demonstrations are going to be about are how to take a diagram and pull out the various pieces of information that I have here. And there are technically 3 pieces of information that I could have here. 360 degrees is 360 degrees. That's the distance around a circle. So what's going to matter here are these pieces of information. The arc length, the actual distance along that curve to get from A to B, or whatever letters are there. The degree measurement, or the central angle, whichever we're given, of that arc. And then 2 pi r, whether we're being asked about circumference, diameter, or radius, all of those can kind of be represented right here. Okay, so let's work through these. I'm going to jump to the whiteboard. All right, part A. Part A, we're given the following diagram. We have a circle, and we have a slice in this circle. Now, in this circle, we have the following information. We're told that the distance from P to A, the center of the circle, to the outer edge is 8 units. You should be able to translate that as the radius. Get used to being able to see that in a diagram and immediately just connecting the dots that has to be the radius of the circle. And then the other piece we're told here is that this angle, this central angle, is 60 degrees. Now, this is a little subtle, and hopefully you can connect the dots back to what we did in chapter 10 here. If I know the size of this slice is 60 degrees, that actually translates directly out to here. That's the measurement of that arc from A to B in degrees. Okay, hopefully you understand that. The reason I point that out is because we won't always be given the central angle. We had entire sections dedicated to saying, like, what if it was an inscribed angle, like the angle was actually, the wedge was out here on the circle, or you had like an X in the middle, or the angle was outside the circle. There were lots of different ways I could find the measurement of this arc. This is the most straightforward way to solve for it. I have the central angle. It's the same exact thing out here. Okay, so before I translate the diagram, let me first show us what the formula is that we're going to be using. I'll use the second version of the formula just so that we have it here. Okay, we were told that the arc length, which is a distance, in this case from A to B. Again, the letters don't matter as much because it kind of depends on the diagram, the letters they use. But in this case, the distance from A to B is going to equal the measurement in degrees of that arc, which now is 60 based on that central angle, out of 360 degrees representing that whole circle, part over the whole. And then that's going to be multiplied by the circumference, or the distance all the way around that circle. So as it's written, it's very intimidating. For the record, the first version of this formula that had written here had this 2 pi r in the denominator over here. It's the same formula, it's just moved over there. And in this problem, we are asked for the following. They want the arc length. They want the arc length of arc AB. This is our question mark. This is the piece we're being asked for here, based on the information in the diagram. So here's how you translate what you're given. Okay, there are various pieces I need in this equation. There are actually 3 pieces in this equation that I need in order to solve for something. Typically, one of those pieces is the piece I'm asked to solve for. In this case, arc length. So this is my unknown. This is my question mark. So there are 2 other pieces here I need. I need the measurement in degrees of that arc. And then I need either the circumference, diameter, or radius of this circle. And I do have the radius here. So what I typically do is I first organize the information that I'm given into those 3 categories. Arc length, this is the piece I'm solving for. The measurement in degrees of that arc. In some cases, I need to solve for it. Here, it was just a simple translation of taking that central angle and applying it to that arc. So in this case, it's 60 degrees. And then the other piece will either be radius, diameter, or circumference. In this case, based on the diagram, it's a radius. So radius here is 8 units. Now I have everything I need to plug in. I'm just plugging it in, solving for the piece I don't know, which again is arc length. So the math at this point is basically just calculator work. So when I plug this stuff in, I'm going to end up with the following. Okay. I don't want to write this over and again, so I'm just going to leave it blank right here because it's the piece I'm solving for. But measurement of arc AB was 60 degrees. And that's still over the whole circle, which is 360. So this will end up reducing down to tell me what size slice this is going to be out of the whole pizza. And then I'm going to multiply this by 2 times pi times radius, radius here being 8 units. So I'm just doing calculator work over here. This fraction can reduce. 60 over 360 reduces down to 1/6. What's the significance of this 1/6? This tells me the size of the slice relative to the pizza. It's 1/6 of the pizza. And then over here, I can multiply the 2 and the 8. I'll keep it in exact form for right now, but that's going to be 16 pi. So now let me combine some stuff together. Anytime I multiply fractions, I can multiply straight across. Technically, the 16 pi is over 1. So when I multiply numerator to numerator, I end up with 16 pi. Denominator to denominator, I end up with 6. So that right there is my arc length. But I can reduce that fraction. 2 goes into top and bottom. 8 pi over 3 is my reduced answer in exact form. If I wanted to do a rounded form, I would use 3.14 for pi. So 3.14 times 8, whatever that result was, divided by 3. But this is the arc length in whatever units it told me. If it was in feet, that would be in feet. Okay, so just to give us a little bit more of a familiar type of look right here, what would this be in approximated form? Don't be afraid to use your calculator. So I would have 8 times 3.14 in the numerator, divided by 3 in the denominator, about 8.37 units. That is the distance along that curve from A to B. That's the approximated version. You'll be asked for either. It's harder to come up with the exact solution. Just keep pi in there as long as you can. All right, well, at this point, that problem's done. We've solved for the arc length. So now let me show you a couple different versions where it's just different information in the diagram. Erase that diagram too. All right, I'll go through these a little bit faster. I'm not going to go through the actual solution process. You can find that on Google Classroom. So it's mostly just about how to pull the information out that we are given based on the picture, the diagram. Okay, so in part B now, we're shown the following circle. They give us different letters, and that's okay. Now it's X and Y and Z. And then the information that we're given, we're told that this central angle here is 40 degrees, which again translates directly to that arc measurement in degrees. And then we're told now that this arc length is 4.19 inches. So the distance along that curve from X to Y is 4.19 inches. That's the arc length. In this problem, we're asked for the circumference of the circle, the distance all the way around. But again, it's going to break down to, if I'm going to use the same formula, all that would change here would be XY and XY as opposed to AB. But I'd still need to know, okay, arc length. This is one of the pieces I'm actually given here. This would be 4.19 inches. I need to know the measurement of that arc. In this term, it'd be XY. This has to be in degrees. And nice thing here again, 40 degrees central angle. That's going to be the 40 degrees out there as well. So when I do 40 over 360, that will tell me the size of the slice. Spoiler alert, it's going to be 1/9. And then the last thing I need to know is either the radius, diameter, or circumference. And in this problem, we're asked for circumference. Now, how would that work here in this problem? 2 pi r is circumference. So actually what I can do right here is replace that 2 pi r with just solving for C. And just walking through the solution right here, I'd plug in 4.19 over here. I'd put that 40 degrees for that degree measurement of the arc right here. 40 over 360 reduces to 1/9. If I wanted to solve for c, I'd multiply both sides by 9. 9 times 4.919